So one of the days of your test, you'll have a document that looks a lot like this with some data that I'll ask you to make a histogram out of. I will provide the table just like this, and if I'm really feeling nice, I'll have the data ordered for you too. To start out, let's find our class width. It looks like the lowest number here is the 28, the highest is 150. So remember, we find our class width by taking 150 minus 28 and then dividing by how many classes. In this one, it asked me to use 5 classes. That comes out to 24.4, and remember that we always round up. Even if that was a whole number, we would round up. So 25 will be our class width. We're going to start our class limits with our lowest data value. And remember that it's smartest to get those first lower bounds first, and we're going to do that by adding 25. Now that we have those lower bounds, we can check the upper bounds by looking at, I want to get up to 53, but I don't want any overlaps. So I'm going to put any 52s in this category and 53s in the next. And if you're not sure what that last upper bound should be, you can always just take your previous one and add 25 to that. Remember, the class boundaries just go a half point below and a half point above, so this one will go from 27.5 to 52.5. Why do we do this? Because then our classes are connected on that number line. And remember, our histogram bars have to be connected. To find the class midpoint, remember, we will just take the average of the lower and the upper bound. And if you're doing it right, you should be able to just add that class width each time. Why do we find class midpoint? Because some histograms, they prefer to label that x-axis with the midpoints so that you have a value that's right in the middle of each bar. Next, it's time to tally. With this little information, you wouldn't have to make a tally. I know that I'm going to look for the numbers between 28 and 52. Maybe I just want to do it this way since it's already nice and ordered. Relative frequency is a comparative number, so I'm going to compare the 5 children in this category to the 20 total children. And those can either be written as decimals or percents, your choice. Double check that those all add up to 100%. You know, we might as well double check our frequency too to make sure that all adds up to 20 children. It's time to make our histogram. Maybe we should just do the title and the labels right away so we don't forget. I normally don't like these axis breaks for my y-axis, but I don't feel like it's going to misrepresent any information if I use it on the x-axis. We want to make sure that these 5 bars are nice and equally spaced. And we could either number each of those tick marks with the class boundaries. Like I said before, some people you'll see labeling the midpoint of each bar. I'm going to stick to what I'm used to. I wasn't asked to make a relative frequency histogram, so that's why I decided to just go number of children up the y-axis. Looks like my tallest frequency will be 7. What a lovely little histogram. I'm not sure what I would describe the distribution as. Not quite mound-shaped, maybe a little bit skewed right. That would be a tough one. Now that we have just the histogram, what can we tell and what can't we tell? Well, I know how many children are in each of those classes, but I can't really tell individual data values. Except that I know that the lowest numbers of pieces would have to be 28, because that's how that first class is constructed. I don't know what the highest would be. Could be 152, but maybe not. So that's really the only data value we can even come up with. Otherwise, we'd just be relying on those class midpoints if we wanted to think about averages or anything. What I mean by that is, remember how the midpoint on this bar was 65? So we could just pretend that all 7 of those kids had 65 pieces of candy, just to get a rough estimate of what we're looking at for data values. I think we could use some Ogive practice too. Remember that ogives are just a cumulative frequency graph. The x-axis is going to be labeled the exact same way. But remember, up the y-axis, we're going to have to get to a cumulative total of 20 children. I can tell you 2 points on this graph right away. There are 0 children that got fewer than 27.5 pieces of candy, and there are 20 children that got fewer than 152.5 pieces of candy. At the 52.5 mark, we need to count how many children got fewer than or equal to 52 pieces of candy, and that was 5 of them. Now once we get up to 77.5, we're counting those 5 plus these 7, so we're up to 12. Once we get up to 102, that adds a number 3. Plus 2. Remember that these slopes are representing how tall those bars were. This one goes up by 5, and that was a frequency of 5 bar. This one goes up by 7. That's why this one was so tall, because that was going up by 7. Up by 3, up by 2, up by 3 again. That's standing for the height of each of these bars.